Okay, my budding mathematicians, this is the second of two intro videos, and in this one I want to cover some basic content that you need to know. Four things here: the formula book, command terms, technology, and review. Okay, so the formula book. First things first, as of right now, in summer 2019, if you Google MathHL formula book, you will not find the correct one. You're only going to be able to find the formula book for the previous curriculum, which has a lot of the same stuff, but a lot of it's quite different. So please don't do that. For right now, you've got to get your formula book from me, or if you're not my student, then from your teacher, because they're only available on the IB site, which you need a username for. If you're watching this video 3 or 4 years after it's been published, then yeah, I'm sure you can find the formula book very, very easily online. But for right now, you need to get it from me. And you'll know you have the right one if it says Mathematics Analysis and Approaches. Oh yeah, that's the other thing. There's also the other IB course, Applications and Interpretations. So you wouldn't want to accidentally acquire that formula book because that's going to be way off. Okay, as we go through the course, I will be sure to mention what formulas are in this book and which ones are not, and I'll also tell you where to find them. When I tell you where to find them, I'll tell you what topic they're in, so we can see that this is broken down into 6 sections. We've got prior learning, which is some really basic stuff, and then we have number and algebra, functions, geometry and trigonometry, which includes vectors, statistics and probability, and calculus. So I'll mention what topic that the formula is in. And then after that, maybe I'll mention what page it's on, or maybe I'll give you a subheading. So for example, if I were talking about this compound interest formula, I might say, hey, it's on page 3 of the formula book, so you can find it there. Or I might say, compound interest is in SL 1.4. So these numbers are tied to the official syllabus from the course guide. You don't really need to worry about what those numbers mean, but the formula book is broken down into the SL formulas first. So here in topic 1, we've got SL. It starts at 1.2. There's no formulas from 1.1. Skips 1.6. This is why I'm saying, like, don't really worry too much about those numbers except as reference points. And then we have the HL parts, which start at 1.10. So the HL starts after the SL ends. I would never have laid out this formula book like this. It's pretty annoying for me in a few places, but whatever. I'm not in charge. If you have like a friend or an enemy, whatever, taking the SL course, they get the same book and they have to like skip over all these HL formulas. So anyway, that's your formula book. So once you get a copy of it, it would be good to look through it, take note of what things you've seen before, what things you know already, and just start to develop a mental map of where everything is so that you can find it as efficiently as possible on exams. Okay, so that's the formula book. Next, I want to discuss command terms. Okay, so these are the instructions that will show up in examinations. And you need to be able to understand what these words mean because some of them are similar but very distinct from others. And there's quite a few of them, as we can see. Now, don't be overwhelmed. Some of these words, like, really very rarely, if ever, show up. I'm going to draw your attention right now to a few that I think are the most important. So starting off with the very first one, calculate, obtain a numerical answer. Here it is, showing the relevant stages in the working. So that means you got to show your work. If you only get the correct answer and you don't write anything down, you're not getting credit for that problem. Like you're getting 0 marks. Okay, and when I give you exams, I grade according to the official IB mark schemes to the best of my ability to do so. And if the instructions say to calculate and you don't show the relevant stages in the working, you're not getting the points. Now, what are the relevant stages in the working? That's going to really depend on the question, so I can't answer that thoroughly here. But it might be doing some algebra. It might be sketching a graph or something like that. Something to let me know what your process was and that it wasn't cheating or guessing. Okay, second one, comment. So give a judgment based on a given statement or result. So that means like you're going to be using get ready for this, words in English to, well, comment on the result of your problem. Part of this course is about communication. There are marks that you score on exams for reasoning, that you're going to have to write some full sentences from time to time in order to score those marks. Okay, next I want to go down here to determine. So determine says obtain the only possible answer. Determine doesn't really say that we need to show any work. So I think determine we can just write down what the answer is. You might have work to do, but you don't necessarily have to show it. Next would be draw. Labeled, accurate diagram using a pencil. In our class, I won't enforce that rule, but on the real IB exam, you must use a pencil for these. We're going to use a straight edge of some kind. Things are going to be drawn to scale. We're going to have graph paper for this. If it says draw, it needs to be accurate. Okay, we're going to compare that. Actually, we'll skip down right now. Compare that to sketch, which I think comes up more often. The sketch just gives a general idea of the shape of the graph that we're discussing and has the relevant features. The relevant features might be where it crosses in the axes, where are the maxima and minima. Once we get into calculus, things like points of inflection. It does not need to be drawn to scale. It does not need to be super precise. Draw does. No straight edge here for sketch either. Okay, so those two we really need to know the difference between. Explain. This is another one that's going to use words. So if I see explain, that means I want to explain. And a sufficient explanation will generally not be just some mathematical notation. Find. This is a big one. This is like probably my second most important one. Find shows up all the time in problems. Very common command term. And again, this is showing the relevant stages in the working. What's the difference between calculate and find? I don't know. They both, we just say obtain the answer. Calculate says obtain a numerical answer. Find says obtain an answer. I don't know what answers are going to be non-numerical for us, but they basically mean the same thing. Find, show the work. Next, hence. This is the most important command term, I think, that we need to get used to as new IB students. Use the preceding work to obtain the required result. So a lot of IB problems will have like part A, B, C, however many parts there are. When you get up to like part C says hence, that means you need to use the results maybe from part B and or part A to proceed in part C. This could come in two varieties. One might be where the previous part was like, hey, find the answer, and you need to find the answer and then use the answer in part C. And guess what? If you didn't do part B, then you can't do part C, and that sucks. But that's not always the case. Sometimes part A might be, hey, show that this expression can be rewritten in this other way. So you're going to be taking a very complicated expression, and they're giving you the answer for how you could rewrite it. And then part B might say, hence, do this thing, and then it'll give you the really complicated expression. Well, even if you can't do part A, you can still use the result of it because you know that the complicated expression can be rewritten in the simplified form, even if you don't know how to do that, which means you can substitute in that simplified form into part B and then work with it there. All right? The important thing to recognize with a hence is that if you try to do the problem a different way, if you don't use the preceding work because you have some other idea, even if your idea gets you to the right answer, if you don't use the preceding work, you're getting none of the marks. So that's a really important one to keep in mind. We can contrast that with the one right below. It says hence or otherwise. It just means, hey, there's a suggestion to use the work above, but you can actually do it any way you want. So it's kind of like a little hint, like we think you should use it using the following, the previous steps, but you don't have to. Okay, next page. So justify. This is another one that's going to be reasoning marks. So if you see justify, that means you're going to want to use full sentences. Then we jump down to prove. Prove, we are going to have multiple types of proofs in this course. Previously, the only type of proof was proof by induction, and the problems always said, prove by mathematical induction. So they would tell you how to do it. As of right now, I don't know what the problems are going to look like in this new course. They might say prove by contradiction or prove by induction. So they might still tell you what type of proof they want you to use. Or they might just say prove, and you'll have to decide the best method to use. I don't know. But we'll talk more about proofs when we get to them in the course. And I don't know, perhaps in a few years I'll remember to update this video as I find out what the answer to that is. Next, we've got show, and also show that. I don't understand why these are both here, because grammatically, I don't know how often you could write show when you couldn't also write show that. Anyway, we're basically, for both of these, you're given some information and they're telling you what the answer is in advance, so you just want to show that the answer is correct. Okay? The key for a show, or a show that question, is that you never, never, never cross the equal sign. So just as a quick example, if it said show that these two expressions are the same, what we do not do is say, okay, well, I'm going to divide everything by 2, so that gives me x plus 1 plus 2 is equal to x plus 3, and then, oh, look at that, 1 plus 2 is 3, so I get x plus 3 is equal to x plus 3. That's not showing that they're equal, because, this is key, when I divided by 2, I was already assuming that they were equal. And that is mathematically not rigorous enough. If I am showing that they are equal, I can't begin by assuming that they are equal. So whenever we have a show that question, I always say just don't cross the equal sign. Do whatever you need to do to the left-hand side, do whatever you need to do to the right-hand side, and eventually they should match up. So obviously in this case, we would just distribute the 2 and then recognize that 2 plus 4 is equal to 6, and now they're the same thing. That's how we're going to do a show that question. We've already discussed sketch, solve. This is another one where we're going to have to show some work. Could be algebraic, numerical, or graphical. Again, solve is very similar to a find or to a calculate. State. State does not require any work. So state just says write down the answer. And actually, I've just said one that I'm about to mention, which is write down. State and write down, I don't really know what the difference is, but really don't need to show any work for either of them. Oh, and verify. Should have mentioned verify when it came to the show that, because this is the other side of that. Verify is what we did here when I divided by 2. That's verifying the fact that they are. It's not showing that they are. Let me show you another example for that. Verify might say, verify that x equals 3 is a solution of the equation of 5x plus 1 is equal to 16. On the left, I'm verifying that 3 is a solution to the equation. On the right, I'm showing that 3 is a solution to the equation. All right, you see the difference? Okay, that's all of the command terms that I think are really, really important. Like I said, some of the other ones are just I've rarely, if ever, seen, like investigate, the compare and contrast. You really tend not to see these in math papers. And then some of them are only specific to topics we haven't seen yet, like differentiate and integrate. Those are specifically calculus terms that we don't need to worry about yet. All right, the third thing I wanted to discuss was the calculator. Really, all I have to say about a calculator is you need to have one. All right, don't be borrowing one from a friend or from a teacher in class and on exams. You really want to own your own calculator so that you can get used to how it works at home. I've had far too many seniors that I've taught in the past who come to me in like April of their senior year and say, hey, can you explain to me how to use the calculator for all this stuff for like paper 2 because I'm not very good at it. Well, if you had your own calculator the whole time and you had a chance to practice it at home, you'd be a lot better at it now already. So I want you to have your own calculator. And I don't really care what graphing calculator you use. These would be my personal recommendations for graphing calculators for this course. The TI Nspire CX2 CAS, great calculator. You can use that on IB exams, AP exams, SAT exams. You just can't, at least last I checked, you can't use it on the ACT exam, but that's the most updated one out of TI. You could also use the TI Nspire CX. Notice that this one is not a CAS. The difference is this first one, you can turn off the CAS function using press to test mode, which we'll be using in my class. And all you need to know about that is like the CAS has functionality that's illegal for the IB, so you need to be able to turn it off. So the CX2 allows you to turn it off, whereas if you were to purchase the CX1 CAS, you cannot turn the CAS off. So that calculator is straight up illegal in my classroom. If you try to use one, I'm accusing you of cheating pretty much right off the bat. So don't try to use one of those for me. I'm not mentioning the TI-84 because the TI-84 sucks. Okay, the TI-84 is a very old calculator. It's been out since I was in high school. You should get a better one. I'm sorry if that's the one that you have. I'm sorry if it's a hand-me-down from an older sibling or whatever, but quite frankly, you deserve better, and you're already behind in the game if that's the calculator that you're trying to use. You can use it. I'll work with you. I know how to use it, so I can help explain it to you in person, but I will not be referencing how to use it at all in my video series. And then we've got a couple other ones out there because TI kind of has the market cornered in the US, so they tend to have higher prices. I don't know what the cost of the HP Prime or the Casio whatever are. I don't even know what models for Casio there are. They usually start with FX, I think. But the HP Prime is a touchscreen calculator, so that's pretty cool. I got to play with one of those one time. I keep telling myself I want to buy one, but haven't gotten around to it yet. And the Casios have a good reputation, generally speaking. They're pretty popular in Europe. They also tend to be cheaper, significantly cheaper than the TI. The only thing about those two calculators is if you're going to get one of them, you're on your own. I can download documentation and give it to you that'll maybe give you some tips, but I'm not going to figure out how to use your calculator for you. That's totally on you. So those are your options, and in my videos I will be explaining how to do stuff on the TI Nspire CX1, although the functionality is identical in the CX1 and the CX2 as far as I know. Tell me if you spot anything, if you own a CX2 that you think is different on yours than on mine. And also under the umbrella of technology, we have websites that I think you should be familiar with. So Symbolab and Wolfram Alpha are two that I go to all the time when I have something complicated that I need to do that a calculator just isn't appropriate for. So like if I want to see some steps involved, sometimes they'll show those. If I want to see, I don't know off the top of my head, but they can do some advanced stuff. So these two sites are both pretty nice. They're similar but different. I don't really know what one is better for than the other, but I use them both. And finally, I use Desmos all the time. You'll see it a lot in the videos for graphing. I just find it to be nicer. It's easier to use than the calculator software for a lot of graph imaging that I'll be including. And that brings us to review. So as I said in the last video, if we want to get good at mathematics, we need to be doing mathematics. And likewise, if we want to get good at IB questions, we need to do a lot of IB questions. So you got a couple of options here for how to prepare for these exams. First, you could try to find past papers. Now the thing is, IB past papers are copyright and are not legal to be handed out. So I can't really recommend to you here where you could find those. Sorry. What is free and legal, however, is all the stuff in the blue. So those are all various examination boards from I think they're all from the UK. I don't even know. I don't know what all the letters stand for. But basically, these are things that are really similar exams to what we do in IB. And if you just Google AQA, past papers, and then start choosing some math stuff, or OCR, past papers, and again, go through the website and find math things, you'll find past questions and answers as well, with mark schemes, in fact. The only thing about that is the curricula aren't a perfect match for ours, so some questions might be too easy, some questions might be content that we've never learned, and also you have to just go through entire exams to find questions that you want. They're not really like separated by topic. But I don't know, maybe if you're like bored some weekend, you're going to sit down and take a bunch of exams from these other qualifications. Third option, you could, like use other IB textbooks. I have a growing collection in my classroom of textbooks that I can lend to you, and I certainly do take questions out of those on my in-class exams from time to time. So if you feel like studying a particular book and seeing if you can get lucky with it, be my guest. Some textbooks are more similar to IB problems than others, however. So for example, the Haza book, the questions in that tend to not be too similar to IB exam level, whereas the Cambridge textbook from the previous curriculum, I thought at least, was very similar to IB level questions. So books will vary, but that's certainly a place you can look. And then finally, just throw it out there, we also have the advanced placement exams from the United States. Some of the topics that we'll see, especially like for AP Calculus, some of that will overlap quite nicely with what we do. And AP Stats would have a lot for the mathematics applications and interpretations course. Not so much for ours, but a little bit once we get up to those topics. And that's for AP, you're only looking at the free response questions because those are all available for free online, whereas the multiple choice are not. And who wants that anyway? Multiple choice is easy, and we don't have any in our course. Now, I'll make another video later on where I go into all this stuff in more depth, and I'll show you how to navigate the websites, stuff like that. I don't really think that's necessary at this point in time. But that concludes the introduction to the course. Life is good for only two things: discovering mathematics and teaching mathematics. I think I'd expand that list a little bit myself, but those two would definitely be near the top of my personal list as well. And now that we've covered these 4 basics, you are ready to begin your journey into mathematics, analysis, and approaches HL. You are ready to begin discovering exciting mathematics, and I'm ready to begin teaching it to you. So, without any further ado, let's begin Chapter 1.